Okay, here's the next problem. You have a K cube. A cube is, so for example, in 2-dimension, a cube is just this, okay? In 3-dimension, the cube is, okay, this thing. अब इसके अंदर think of this cube as a graph, okay? Think of this vertex as, this point as a vertex, this point is a vertex, this point is a vertex, and in these lines as edge segments. So in here, for example, your vertices, go ahead, read the paper, read the question, and let me get back to you in just a second. All right, so you can think of them as so you can label these vertices with zeros and one. Think of them as strings of zeros and one. Okay, let me call this one as 0, 0. So this vertex is connected to all the vertices with which there is only 1 bit difference. So it will be connected to 0, 1, and it will be connected to 1, 0. Okay, and these two will be connected to 1, 1. Similarly, you can start here with 0, 0, 0, and this would be 0, 0, 1. This would be 0, 1, 0, and this guy in here would be 1, 0, 0. Okay, and let me label this guy 1, 1, 1, and this would be 1, 0, 1, and this is fine, and this would be 0, 1, 1, and this would be, no, so this is 0, 1, 1. This is this node is 0, 1, 1, and this node is, let me just make sure that it's 1, 1, 0. Okay, so anyhow, so this is one way to construct a graph of this form, that you label each of these vertices with k-bit string, and their neighbors are k-bit strings which differ from this node with only 1 bit. Okay, show that the k-bit k cube has 2 k vertices. This part is, I think, quite easy. There are this many edges. Who is going to argue why there are this many edges? And this is a bipartite graph. इन दोनों के लिए मुझे proofs चाहिए. How do you count the number of edges in a k cube graph? Ubaid, are you there?
Yes, sir.
Okay, call someone at random.
Okay, Sufyan Said, are you there? Muhammad Sufyan Said. Okay. Sayyida Dua Aslam. Hamza Fareed. Next is Muhammad Ahmed.
Keep a list, okay? इनको absent भी करना है.
Okay, sure. Muhammad Ahmed, Maham Amir. Amna Akbar.
Yes, sir.
Amna, is that you?
Yes.
Now we want to count the number of edges in K cube graph. How do you think we should count them? Do you understand the definition of K cube graph? Yes, no?
I'm still a little confused.
Okay, do you understand what's the degree of each vertex? So for example, 0, 0 की क्या degree होगी? So if you have a 3 cube graph, okay, and 0, 0, 0 is connected to 0, 0, 1, 0, 1, 0, and 0, 1, 0, 0. Okay, so what's the degree of this node? Iman, what's the degree of 0, 0, 0?
Um, like you're asking for the degree sequence?
No, just the degree of this one vertex.
The degree will be 3.
Yeah, degree will be 3. What would be degree of a vertex 0, 0, 0, 0 in 4 cube graph? Yeah?
4.
It would be 4.
Sorry, it will be what? 4?
4, yeah.
Yeah, makes sense. बोलो कुछ कोई बोल रहा था बीच में.
It has 4 neighbors if it's a 4 cube graph. So, right.
क्या?
It makes it degree 4.
Yeah. So degree of this vertex is 4. What would be so the thing is every vertex is connected to strings which differ from it with only one bit, right? So isn't it a regular graph? Isn't it the degree of every node same as degree of every other node?
Yes, sir.
Okay, so these are all K regular graphs. Okay.
Sir,
Yeah.
I think that every vertex will have k edges,
Okay.
and since there are 2 power k vertices, and then we would divide it by 2 since every edge is being counted twice.
Yeah. It came through. What's your name?
Amen.
Okay. All right. So degree of every node is K. We have just established, and there are 2 to the K vertices. Okay. जी हमने अभी किया था और ये काम हम पहले भी कर चुके हैं. The number of strings of length K, binary strings, is 2 to the K. So that's the total number of the sum of the degrees. Okay, and we divide it by 2, get the number of edges, which is exactly what we wanted. Okay. Now the last question: why is this? Is this clear to everyone? Why there are this many edges in K cube graph?
सर ये 2 के -1 क्यों है एक दफा बता देंगे.
So this is the sum of degrees. हमने establish किया है कि it's excuse me guys. So the sum of degrees is K times 2 to the K. Okay. और हमने ये कहा था कि the number of edges is equal to this term divided by 2. Okay, we divide this thing by 2, we would get K times 2 to the K minus 1. Okay, ये 2 पर जाएगा तो ये minus हो जाएगा. Okay, so that's the reason we get K times 2 to the K minus 1.
Yes, sir.
Okay, now the last question: why is this graph bipartite? How do you show that this graph is actually bipartite?
सर वो इसको हम वो स्क्वायर की तरह कर सकते हैं, डायगोनल्स को बना साइड है उसके डायगोनल्स जो हैं वो आपस में नहीं है कनेक्टेड, तो उनको हम एक साइड में रख सकते हैं.
So thing is, this will become very complex now. जब ये तो 3 dimension में you can see it, right? When you go to, for example, 100 dimension cube. Oh, I'm sorry, guys. It will become very rough. Okay, so that's yeah.
सर इसको हम यूं नहीं प्रूव कर सकते कि अगर हम एक इसका फेस बना के उसमें दिखा दें कि वो बाइपार्टाइट है और उसके बाद बाकियों में उसको प्रूव कर दें?
No, and that's not the way to formally prove it. There's a very easy way to see why this is bipartite. Look at the strings that you use for the vertices.
सिंगल चेंज है सब में.
Repeat, please.
With respect to their neighbor सिर्फ एक वैल्यू चेंज हो रही है.
Okay, yeah, ठीक है. How does it prove that it is bipartite?
क्योंकि हमने असल में यही चेक करना होता है कि नेबर्स के साथ वो जो पिंक और ब्लैक से जिस तरह आपने एक्सप्लेन किया था ये भी उसी तरह भी प्रूव नहीं हो रहा.
Almost. So for example, if I start with this guy, this is black. इसके ये 3 नेबर हैं जो कि पिंक हो जाएंगे, फिर उनके जो 3 नेबर हैं ये ब्लैक हो जाएंगे और उनका ये नेबर है which is pink. So it is bipartite, right? But how do you prove it in general? That's the way to do it. Okay. यहाँ पे थोड़ा सा एक छोटा सा idea missing है, which I want someone to say out loud.
We can add the vertices and the coordinates of the vertices.
Okay. Then.
So if the sum is even, that means that the graph is bipartite.
Yeah. Perfect. So perfect. Awesome. That's great. I'm really happy to hear this. The thing is, look at the number of ones in each of these bits. Okay. I'm going to give you a plan. The plan is that I'm going to color all the vertices जिसमें number of ones even है black, and I'm going to color all the vertices जिसमें number of ones odd है pink. Okay, that's the plan. And the claim is that you will never have an edge between 2 pink nodes and between 2 black nodes. And the reason behind is simple, in the sense that if you start with the black node, which means that the number of ones in here is even, this guy is connected to all the vertices which are at distance, coordinate wise distance 1 from this guy. Okay, which means कि अगर इसके अंदर even number of ones हैं तो by definition इसके neighbors में odd number of ones होंगे. Okay, एक bit change होगी, exactly एक bit change होगी, which means कि number of ones will definitely switch from even to odd, which means कि इसके जितने भी neighbors हैं उनमें से कोई भी neighbor black नहीं होगा. And same is true about the pink nodes. Okay, if I start with the pink node and the number of ones are odd, तो उसके जितने भी neighbors हैं, all of those neighbors are the ones which change only 1 bit. Okay, वो या तो इस एक bit को 0 कर देंगे या फिर किसी और bit को 1 कर देंगे, which means if there are number of ones are odd here, the number of ones in the neighborhood would be even, which means कि इसकी neighborhood में कोई भी pink color का node नहीं होगा. Okay, so this gives you a perfect coloring which proves that the graph is bipartite.
सर
क्या
सर इसे एक और तरह से भी कह सकते हैं कि हम इसे 2 उसमें डिवाइड कर दें, रेक्टेंगल्स में या स्क्वायर में, सामने वाली और पीछे वाली.
So the thing is, वो ये जो बात है ना, ये आपकी जैसे if you go to 4th dimension, ये argument valid नहीं रहेगा. There is no definition of a front and a back in dimension 4. Right? 3 dimension में तो आप इसको visualize कर सकते हैं ना. But once it goes to higher dimension, ये जो geometric argument है, it falls down. Front, back, face वाला argument नहीं रहेगा आपके पास.
सर ये इवन ऑड वाली बात रिपीट कर सकते हैं?
Yeah, sure. So here's the thing, go to any cube, 100 dimension, whatever, I don't care. उस cube के अंदर The definition of the cube is that every node is connected to every other node which is at distance 1 from that node. And by distance I mean कि वो उसकी string के अंदर सिर्फ एक bit को change करेगा. किसी bit को वो 0 से 1 करेगा या किसी bit को 1 से 0 करेगा. 2 bits को change नहीं कर सकता, 0 bits को भी change नहीं कर सकता. He must change exactly 1 bit. Okay, which implies that if the number of ones in the vertices name the string is even, तो फिर उसकी neighborhood के vertices में number of ones odd हो जाएंगे. अगर उसके अंदर number of ones odd थे तो उसकी neighborhood के vertices के नाम में वो even हो जाएंगे. Okay, which means that if I color odd labeled vertices with one color and even labeled vertices with another color, I will always have the result that the nodes with the same parity are never connected by an edge. Okay, because I only connect two vertices by an edge if they are different by 1 bit. But the consequence of changing 1 bit is that number of ones की जो parity है वो change हो जाती है. अगर वो odd है तो वो even हो जाएगी, वो even है तो वो odd हो जाएगी. Okay, regardless of the length of the string, the argument works in the 100th dimension. जितनी बड़ी आप string ले ले, अगर आप उसकी सिर्फ एक bit को change करेंगे तो उसकी string की जो parity है वो change हो जाएगी. वो अगर odd थी तो वो even हो जाएगी, वो even थी तो वो फिर odd हो जाएगी. Make sense?
यस सर बस ये बता दें कि जो लेबलिंग आपने की है ये
क्या?
किस तरह की है, ये मतलब
So-
लेबल्ड
so-
ग्राफ होगा कि हमें कुछ करना पड़ेगा?
नहीं, लेबल्ड ग्राफ नहीं है. द थिंग इज ये डेफिनेशन है क्यूब की. ओके, ये जो मैंने शेप बनाई है ना, ये आपको अंडरस्टैंडिंग के लिए बनाई है. द क्यूब की जो डेफिनेशन है वो ये है कि यू हैव 2 to the k vertices. ओके, पढ़ी हुई है. और द डेफिनेशन सेज दैट फॉर एवरी वर्टेक्स, देखो आपने ग्राफ को कैसे डिस्क्राइब करना होता है, आपने ये बताना होता है कि उसकी वर्टिसेस कौन सी हैं और हमने ये बताना होता है कि उसके एजेस कौन से हैं. ओके, वर्टिसेस के लिए आपने बता दिया कि यू हैव वर्टिसेस जिनके लेबल्स आपके पास हैं 0 0 0 0 0 1 whatever, all possible strings of length k. ओके, और उसके बाद सॉरी उसके बाद आपने एजेस का बताया और आपने कहा कि go to every vertex, the neighborhood of that vertex is defined by those vertices which are different from this vertex by exactly 1 bit. Okay, so mera vertex set would be so for example 3 dimension mein this is my vertex set 0 0 0 0 0 1 0 1 0 1 0 0 0 1 1 1 0 1 1 1 0 and 1 sorry and 1 1 1. Okay, so this will define my vertex set. Similarly edge set में मैं ये कह रहा हूँ कि मैंने आपको edge set लिख के नहीं दिया क्योंकि it's a huge set. Okay, मैं आपको ये बता रहा हूँ कि v1 and v2 is an edge if distance of v1 and v2 distance of v1 comma v2 is equal to 1. Okay, मैं इसको यहाँ पे भी लिख देता हूँ आपके लिए. so edge set को ऐसे define कर रहा हूँ कि edge set is all those pairs v1 v2 where the distance of, let me call it ij ji, where the distance of vi comma vj is equal to 1. ओके, अब यहाँ पे मैंने एक चीज डिफाइन की है डिस्टेंस. तो डिस्टेंस मैं ये कर देता हूँ कि डिस्टेंस ऑफ 2 strings is the number of bits on which they differ. ओके, सो फॉर एग्जांपल मेरे पास अगर आपके पास 0 0 1 1 0 0 है और मेरे पास एक और स्ट्रिंग है 0 1 0 1 0 0। तो इसका डिस्टेंस मेरे पास होगा, यहाँ पे डिफर नहीं कर रहे, यहाँ पे मैच करें, यहाँ पे मैच करें, यहाँ पे मैच करें, यहाँ पे डिफर करें और यहाँ पे डिफर करें, यहाँ पे मैच करें, तो इनका जो डिस्टेंस है वो 2 है। ओके, दैट्स हाउ डिफाइन द डिस्टेंस। और मैं ये कह रहा हूँ कि सेट इज दोज पेयर्स जिनका डिस्टेंस एग्जैक्टली 1 होगा। Make sense? That's how you define a graph. It's not a shape, it's not a geometry, it's this discrete description of the set. Are you good?
Yes, sir.
Okay, awesome. So this was sort of I think a nice exercise to see whether a graph is bipartite or not.